This
Good to join.
conference will now be recorded.
Hi guys, so good to have you in the session and that too in Sunday morning. Thank you for joining for an educational session also. Hello guys.
Hi, Ajay.
Hi.
Hi.
So this today's topic will be like refreshing essential high school mathematics. Let me tell you like why it is so important. Because if you can see, almost data science is almost related to tightly correlated to maths. In the sense, at least some linear algebra, some basic concepts we should know. It is very important in the sense if you are not aware of this, it will be like a black box in the sense if you give some input, it will throw some output, but you won't understand like why it is throwing that output and why it is behaving like this and why I'm getting an error, all those things. So it is very important to slightly understand some basic maths. So don't get fear of like maths means I won't be teaching so much. Like in the sense, it's just like basic algebra, vectors, normalizations, all those things. This is like in 12th or engineering first semester, second semester you might have learned. It's just like a brush up session, and you might have already known this concept. And today we will be having an hands-on session also on linear algebra, all those things. So let me tell you also like how linear algebra is important in our machine learning part, all those things. So the basic math concept, these are like fundamentals on these four concepts only. All the machine learning models and then data science, almost everything is built. So once we got a good hold of it, we can learn any algorithm or any path. So why I choose to go in this way is rather than going to algorithm first way, because there are some each and every algorithm there are some math behind. If we can know about some basic concepts of math, it will be very easy for you to correlate when we are explaining about algorithms, all those parts. So if you are from computer science background or not from a computer science background, it will be very easy to understand. I have designed in such a way like it will be very easy for you to grasp. If you have any questions also, please don't hesitate to ask me. I would be happy to help you on that. So today mostly we will be covering on the linear algebra part, and then we will just give an introduction about like what is probability theory and how it will be useful, all those things. So if you take an image, right? So if you take an image, normally we can see that is a flower image, and it has colors, red color, green color. But for the system or for the machine, it's like it forms like RGB color, RGB. So 230 pixels in. If it is like a black and white image, the image pixels will be like 0 to 255. For our eyes, we can see the image, but in terms of system, it sees everything in the form of pixels. This is the first main concept, like why we use linear algebra, because everything is in the form of numbers and matrix. So the image we will be converted in the form of matrix, and then we will be working. So based upon the colors, we will have for each and every cell, we will have a color code, all those things. So this is the main application of linear algebra. And second is when we learn about some basic and advanced concepts. So this is called a neural network. It's like they have almost simulated like how our brain works. So that is called a neural network. So in terms of neural network, if you can see this concept, right? This is like 2 cross 3, 3 cross 2 matrix. So everything will be in the form of matrix, and then each and everything, the weights are all are stored in the form of matrix, vectors, and then all those things. So once you get a good hold of these concepts, it will be very easy for you to learn basics and advanced concepts also in the near upcoming future. So these are like major two applications, and even in form of text also. If you take the cake or laptop, computer, all those things, we might see as a text, but the system will see that as a numbers. So we will normally when we are handling text, we convert the text in the form of numbers, so the system can handle it easily. So yeah, when you are using some user interface or some maths or math, all those things, we might program in one way, but everything will be converted in the form of binaries. If you can see some basic applications of computer, everything runs in the form of binaries. These are like basic things why we need a linear algebra. So hope you might be aware of this concept like solving two equations. So let me just take you this to an example. So it's kindly apologize for my handwriting. It's like since it is system, it's not that good. But if there is any misunderstanding, please ask me. So hope this is like a it is a vector and this is a vector. Vector in the sense like, we will drill down further in the upcoming slides. So this we might be came across some aptitude questions and then some basic like during my 8th standard all those things we might be solving two equations. Hope for this first of all we considering this as an equation 1 and this we will be considering as an equation 2. So first of all, what we will do is we will multiply the first equation by 3 times, the second equation by 2 times, we are just trying to solve the equation so that we can derive the value of x and y. So 6x plus 9y (24), 6x. So first of all, we are trying to cancel out x so that we can derive the value of y. So this will be 4y is equal to 14. So we can change this sign. Plus 6 and minus 6 will be cancelled out, and then this will be like 5y, and this will be a 10. So y will be 2. When you substitute this 2 in this above equation, you can derive x. So if you take 6x plus 18 equal to 24. So 6x equal to 6, x equal to 1. Hope you all might have gone through this basic equation. So why I'm just telling you is just like it's just a refreshing session. At the same time, you can learn so many new things also. If you can substitute this back to this, you can again derive the same equations. For example, if you substitute x equal to 1, it will be 2, 6, 6 plus 2, 8. So whatever we derive, it's fine. So this is how we normally solve when two unknown equations. Then if you come to now if you come to three unknown equation, then again we use the substitution concept, all those things. But if you think if you're solving a two unknown equation, three unknown equation, two unknown equation will be slightly easy. But if the number of unknowns is keep on going up, it will be even more tougher to solve it. If you take three equation, again it will take so much of extra time. Then what about 15 equations, 15 unknown equations to solve through our traditional method? So this is just a records rows and columns in the form of tables. So this is with this help of thing we have to find thing. If the in terms of real world we will have n number of dimension like 1 lakh of dimension records, all those things. So to solve all those things, it will be very tedious to using the traditional method. So hence we are coming into the form of using the matrix. So this concept, why we want to use matrix, if you are very clear, you can be a very good machine learning developer or a data scientist in the upcoming future. If you take the main objective why we are using matrix is to solve even more, even if it's like 1 lakh unknown equations or 10 lakh unknown equation also we can find it very easily. But if you take the traditional methods, it for 2 equation or 3 equation, it will be very easy to solve it. But if you take if the number of dimension keeps on going up, it will be very easy to solve, very difficult to solve. So just refreshing, like hope you got no, a matrix, like just to handle all the in the form of rows and then columns. So with this help, we will train the system, all those things that in terms of machine learning part, we will be speaking later. But generally, just know the terminology. Like normally, we will be using. Give me an example. So now we will say like A equal to 1, 2, 3, 4, 5, 6, 7, 8. So we call this as a matrix, and the dimension is 3 cross 3. Since why it is 3 cross 3 is we have 3 rows and then 3 columns. So this is generally we term this A as a matrix. And then we can represent in the multiple form where it is called as, if we have only one value, it is called a scalar. And if we have a row vector or a dimension or a column vector, this is called a vector. And then if it is like 2 dimension, if it is like 0 dimension, this is called a scalar. So what is a scalar is, if we take a straight line, so this is 0. If it is like 6, so then the point lies here. If it is like -3, the point lies here, somewhere around here. So this is called scalar. Kindly apologize for my handwriting. Okay, so it's scalar. And if you take a vector, now if you can see, this is a vector. So I will just represent you so that rather than seeing in the form of numbers, if you see as an image, it will be storing in your mind very easily. So now we can take a quadrant. So if a vector has 2 things, so one is magnitude, so one will be magnitude and one will be like direction. If you take if you take 1, 2, right? So 1, 2. So the first terminology is called as magnitude or length. The second part is scale is called the direction. So the first value will tell you what is the length. So in terms of, since it is a positive and this is also in the positive, it lies in the first quadrant, and the length is 1. So 1 almost comes here. So this is the length of the vector, and the 2 in terms of y-axis, this is 2. This is 2 and this is 1. So if you can join these 2 lines and if you draw these things, so this is called a vector of 1, 2. So the interesting concepts occurs is that what happens if a scalar multiplied with a vector. So if I have the same 1, 2 and the scalar I have is 3. So if I multiply it, it will be like 3, 6. I'll just draw it in the below so that you can understand. So similarly, in x-axis, that is 3, and in y-axis, it will be 6. If you can just meet the common point. The beauty is, if you can see, when it was 1 comma 2 and now it's like 3 comma 6, the direction remains the same, and then only thing is the length has changed. So that's what happens when you multiply it with a scalar. Scalar is like a one digit number, that is in the sense a unit digit, and then if you multiply this with a vector, what happens if you multiply this with minus 3? If you take minus 3, it will be like minus 1, minus 2, minus 6, minus 3. So minus 3, minus 6 lies in the fourth quadrant. 3, comma 6. So 3 comes here, 6 comes here. Almost this will be the same thing. Only the thing is the direction of the vector changes. So this will be 3 and this will be 6. So this will be minus 3, minus 6. So whenever you multiply a scalar with a vector, you will just follow the same line throughout, like a railways. In the sense, it will be like a. Where is my mouse?
Arjun,
Yes, yes, yes. Please go ahead.
what if we multiply minus 3 and scalar is negative and the vector is positive?
Yeah, scalar can be both negative and a positive.
No, if a scalar is minus 3 and the
Okay.
vector is 1 and 2,
Hmm.
what will be the final outcome?
So you're asking scalar is a 3 and the vector is
If a
1.
scalar is minus 3,
Vector is minus 3.
vector is 1 and 2.
Yeah, it's just like minus 3 into 1, it's minus 3.
Okay.
Minus 3 into 2, it's minus 6.
Then in the previous one, you have given minus 3 into minus 1 minus 2, you have given, right? The vector
So
also minus 1.
actually it was like plus. Is it confusing or can I give another example?
Uh, my only confusion here is if both of them are negative, you can give
Okay,
three
this is the
examples,
case.
right? If scalar is negative, if
Okay,
scalar
then
is
I'll
negative
give
and
you.
vector is also
Yeah, the vector will be constant here. Here it will be 1 2. Here also it will be 1 2. If even though if it is like
okay.
plus 3 or minus 3, the position of the vector, that is the direction remains the same. Only thing is, like if it was like rather than minus 3, if it was like minus 4, it comes here. So the line extends till here. So it was like it will be like minus 4 comma minus 8. I will just give you
Is there any?
another example.
Yeah. Yeah.
So now it will be like 2 4. It is a vector, and in right hand side I will just plot it. So in the x-axis, that is the length, that will be 2, and in terms of y-axis, this will be 4. If you just take here, if you can connect with to the origin, so this will be 2 comma 4. Okay, let's take a different. You want the example with minus, right?
Both of them in minus.
Okay, minus 2 minus 4. Then it comes under x-axis minus 2 minus 4.
Yeah. And if we are multiplying it by minus 2,
Yeah. So this gives 4 and this will be 8.
Then it
So you
comes in
can,
the first quadrant, right?
yeah, this comes in the first quadrant. 4.
Okay.
Let us take this is 8. If you take this point somewhere around here, if you plot this line, it follows the same path line.
Okay.
Only thing is, it's just like a sniper. You can take that as a sniper. The target will be the same. That is, the line path will be the same. Only thing is like zoom in, zoom out. You just can visualize like that.
Okay.
So, but it follows the same path. Even if you multiply with a bigger number or a smaller number, even if you multiply with 0.001 also, it just comes here. But the direction won't change. See, direction won't change in the sense where either it will be like positive direction or the negative direction. The length of the thing changes. So this is what, in terms of geometry wise, if you do a multiplication, this things happens.
Okay.
So now if I go to matrix, you guys would be know pretty concept about matrix. It's just like an it is a two-dimensional thing. So 1 comma 3, 2 comma 4. And if you can take three-dimensional, a equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Now it will be like 3 cross 3. Since it is 3 cross 3, it will be like 3 dimension. So when you plot it, rather than x-axis, y-axis, a new z-axis will come. If you take x-axis, y-axis, z-axis, so yeah, you can easily visualize these things. But if the dimension goes up, if it is a fourth dimension, fifth dimension, or sixth dimension, and if the dimension keeps on rising, it will be very difficult for us to visualize. So a tensor is like normally a tensor 0 is called a scalar, tensor 1 is called vector, tensor 2 is called a matrix, and this can be represented in the form of tensors, because a matrix, if it goes more than that, we can call it as a tensor. So this is like basic maths concept we might have came across. And let me just go through the terminologies in matrix that we commonly use. What is an order of the matrix? So order of the matrix is 2, 4, 6, 1, 3, 5. So this is number of rows is 2. If you can see 3 rows, 4 columns, then it's called 3 cross 4. So now it has 2 rows, row 1, row 2. So that is 2. And then we have 1, 2, 3. 3 columns. So it will be 3. This is called an order matrix. And the square matrix is obviously is like number of rows and the number of columns should be equal. If you take 1, 5, 2, 6, so the number of rows equal to 2. So number of columns is 2. Then it is called a square matrix. So if you take what is an identity matrix, 1 should be in the form diagonals and the remaining part should be 0. This is called identity matrix of size 2. And if it is 1, 1, 1, 0, 0, 0, 0, 0, 0. See, this is called identity matrix of dimension 3. And there are other concepts, it's like row matrix and column matrix and row matrix. One, two, 5, 3, 7, 9. Generally, we call this as a matrix. To take a row matrix and a column matrix is very pretty simple. If you take this part, that is 1, 2, 5, 3, 7, 9. So this will be like row matrix. If you take this part in the column wise, 1, 3, 2, 7, 5, 9. These things will be like column matrix. So a row matrix and column matrix is almost similar to a vector. If you can see in the previous slide, this is a column matrix. See, column matrix, or it is called as also a vector. So a collection of vector is called matrix, and the collection of matrix is called a tensor. So till now, are you guys clear, or you have any questions so that we can discuss, or we can go ahead?
I have no questions also.
Okay, thank you. So the next important, so even though it's, if you're not connecting dots, or if you don't understand like why it's happening, all those things, if you can understand this concept at least to some extent, it will be very easy when you're learning some algorithms or advanced concepts in neural networks, all those things. And this is a very important concept called norm. If you go to interview or if you go to anything, first thing they will ask question is norm. What normally people do is they will learn the algorithm part. They will learn as a black box when the interviewer or somebody asks like how the algorithm runs in the back end, or what's the math behind the algorithm, or like if they ask any questions on vectors or all those things. First thing they will test you on these concepts only. So please give some attention to this concept. If you can understand this concept, the whole sessions will, upcoming sessions will be very easy for you. So what happens is we predominantly will be using L1 norm and L2 norm. Don't just it would be very easy concept, and we can see these concepts with an hands-on session also, and we have arranged for that. So what it do is, when you are doing some algorithm or some machine learning part, the machine tries to learn something. So in order to check how the machine has learned, that is mean absolute error, mean squared error. Mean absolute error is nothing but, let me give you some formula. So let's say we have an 5 to L1 norm. So what the L1 norm is nothing but mean absolute error. Absolute error. To find that is just like absolute of first value plus absolute of second value. This will give 5 plus 2 7. So this is called the length of the vector. If you take L2 norm, it is called mean squared error. So let me give you like why we are using this. Often used when fitting machine learning algorithms. Fitting is like learning machine learning algorithms as a regularization model. So it's just like for the system to learn better. Let me just give you a real-time example so that you can understand it really well. So you have a line like this. So this is like number of experience, like 2, 4, 6, 8, and here this is x-axis, and this will be the y-axis, and here it's like years of experience. Here it will be like salary. $10K. Let's use some decent value. $50K, $70K, $90K. So here we have some points here. So these are like we have data like, for example, on an average 4-year experience earn 30K, 6-year experience earn 50K, and then 8-year experience earns 60K or 70K, and we just plot few more data. So this is how the data looks like, and these are like real-time examples that we can collect, in the sense, on an average. Can you understand this problem statement, guys? Like this x-axis will be the years of experience and the y-axis will be like salary. So you can see a general trend, like as the number of years experience, the salary goes up. Now, for example, I am for example, you guys are the new HR or something, so you want to check the ideal range of your company's salary. If, for example, if suddenly a guy comes with 5.5 years of experience, so what should be my salary slab for him? That is the nominal slab for him. We can keep it as like that. So when you're using the machine learning model, I will try to find the best line. Let me use a different color. Let's use green. So this will be like a vector line. And if I want to give an in your company, if a guy come with like 5.5 years of experience, I'll just check in the x-axis, and then what will be his salary in the y-axis, and it will be like around, okay, I can give this to my salary maximum limit will be 35K and then 45K. Within this slab, I can give a salary offer for him. That's our company normal general. So if you can see, some points can, if you take this point and this point, these are like slightly almost similar, but if you can say, but if you take this 4 years or thing, there will be some error. It should be here, but it is here. So this difference is called error. Let me write. So that is, it should be it should be 20K, but it should be 20K for 4 years of experience in a case, but our system shows 25K for 4 years. If you compare these two things, 5K is error. Guys, can you just follow this example? If you have any questions, please ask me. I will be happy to help you with that.
Yeah, can you repeat that, Arjun? Because we have plotted 20K for 4 years, right? Or the system?
Yeah, just some dummy examples we took, and let me plot here. So it is like, okay, 20K. So based upon our employee record, on an average, we are giving 20K for 4 years experience. Just an example,
Okay. Okay.
not
Okay.
don't dig into each numbers, just a
Okay.
random example, okay? So on an average, you are giving 4 years of experience, you are giving 20K, but based upon your system, it's showing like 25K. If you take this line, right?
Okay.
So errors is just a difference between, for example, if you want to buy a apple for 10 rupees and you gave 20 rupees, the error difference is 10 rupees, right? So it's like how much extra or how much lesser than that. That's to calculate this. For example, if you take this example, it should be 20K, but the system draw the best line so that almost it gives a good amount, good prediction for other things. When we just dig into the this actually this algorithm is called linear regression. Mostly after our basic refreshing, all those things, we will be digging deep into this algorithm. Just for to give an example, I'm just saying. So even if it's like somewhat difficult to understand, or I'm not sure like why it's happening, all those things, just be cool. Like when we will be discovering multiple examples on that. So you can just take it. Error is like. You want something and how much extra or how much lesser you're just paying for that. So that's called error. For example, a student can score is 100, and if he is scoring 85, 15 is what he left. That is called an error. So we can take multiple examples on this error. So to calculate this error, we will be using, yeah, to calculate this error, we will be using L1 norm and L2 norm. So L1 is like absolute error, L2 will be squared. I'll just give you an example for that, don't worry. Yeah. It's like square. So the first term 5 you have to square, plus 2 you have to square, so this is the formula is like b1 square plus b2 square plus b3 square plus bn square. If you substitute this here, so 5 power square 25 plus 4 equal to root of 29. So 29 you can find the root, and it will be, you can 30, you can just like 12 point something will come here. So this is called L1 and L2 norm. Don't worry, we have a Python where we implement L1, L2, all those things. But on an average, you can understand what is L1 and L2 norms, right? Okay, like next you can move on to the, let's jump into some hands-on session. Guys, are you all are connected to internet, and I hope you are connected, and then you have Google Chrome, right?
Yes, sir.
Yeah. Please type Google Colab, and you can open the first link. You guys, please follow. You have to do it in the parallelly so that it will be a good experience. Because though you can learn theoretically and you can see the slides, all those things, but until otherwise you guys practice, it will be very difficult for you to cope up and learn. So I urge you to please type Google Colab, and then you just click the first link. If you have any difficulty, please ask me. It will generally ask you to log in with your Gmail ID or something. Please do the login process. Since I have already done, uh, it didn't ask me. I was already pre-connected to it. You just log in, check whether you can come into this page. If you have any difficulty, please ask me. Once everybody got this page, we can proceed to the next thing. Veer Kumar, Vijay Priya, can you guys get into this page?
We are following.
Super then. Can I proceed further, guys? Okay, then I hope everybody got this page. If not, also please ask me. I will help you on that. So click File, New Python 3 file. File, Python 3 notebook. If you want, this is in the form of cloud. If you want in your local system, you can use Anaconda or Anaconda in your local system. Since the installation will take some time, I don't want to consume your valuable time, that too on the Sunday. So I'm just using this pre-installed thing, so that, for example, you can just check out whether it's working or not. Since it's like first time it's trying to connect, that's why you don't wonder like for just printing why it's taking. See, if you can see here, let me close this. Now it's connected. And can you just do a print line so that can you just guys confirm like everything is working good?
What you close before?
Can you say again?
What you close before to arrive at this console?
File, new Python 3 notebook.
Okay.
So this is the landing page.
Okay. Okay.
So hope everybody would have connected
Yeah,
to
it's
this.
working. Yeah.
Yeah, awesome guys. Then let me go with the form of vectors. Defining vector. Please follow like whatever I write, or if you have any doubt also you can ask me. First of all, like if you might have came across Ash include Kone.h, Studio.h, and then in terms of Java, util, and then string buffer, all those things. This is like header files we will be using in Python. For this, import NumPy as NP. So these are like all the predefined libraries that we'll be using. So first to define a vector, so vector1 equal to NP. So NP is like if I am not using this, every time I have to use NumPy dot array or 579. It won't work. So rather than giving like this as NP, we are using this. So it's just like a nickname. So rather than calling like that, you can just call it as NP wherever you want. And if you want to check, you can just check by printing vector1. So 579. So that's what a vector is. This is form of this is a row vector. And let me defining another vector. So this will be vector2 equal to np dot array, and this will be like 2 4. Let me take some easy examples so that it will be easy for multiplication. And 1 2 3. Here 2 4 6. Print of vector2. So now we have two vectors. Guys, can you able to follow this? Or do you have any doubts on this? Hello?
Can you give me a minute, Arjun? I'm just
Yeah, yeah,
trying.
yeah. Please, yeah. Please go ahead. That's right. So initially we are just checking like whether everything is connected or working, and then we are just using the header files, and then in the here we are using 1 second. Oh, sorry guys. So here first we are defining a vector 1, and here we are defining another vector 2. So NumPy is, if you just check in the internet, NumPy, it is mainly used for handling effective multi-dimension generic data. In the sense for mainly using for arrays, matrix, and then all those concepts, we will be predominantly using NumPy. There are so many functionality in this. Like let's whatever theoretical
So if
concept we have seen.
you want to define a vector, we have to give it as np dot array. Is it right?
Exactly. Yeah, correct. You can just check type of vector one. See, n dimensional array. So if it is like 1, it is a vector. If it is like 2, it is a matrix. So now let's do multiplication of two vectors. Like vector 3 equal to vector 1 asterisk vector 2. Okay, print of vector 3. So it will do an element-wise element multiplication in the sense 1, 2, 2 ones are 2, and then 2, 4, 2 fours are 8, and then 6 threes are 18. So this is a multiplication of two vectors. So if you guys can follow this, like initializing a vector and then multiplying a vector, or else you can add a vector. You just take 2 minutes, you just see the code, and you just try to do the hands-on. Like after that, we can just check out with matrix, all those things.
The output is tuple or array?
Guys, can you follow this code, guys?
The output is tuple or array?
It's an array, n-dimensional array.
Okay.
Since we are using one-dimensional array, so we are getting an output as an one-dimensional array. If we are gonna multiply with a matrix, so the concept will be like so if you are gonna multiply 3 cross 2 and then 2 cross 3 matrix, we will get a 2 cross 2 matrix. So it's generally the idea is that these are like matrix property. So based upon that, we will get the output, the dimensionality. Guys, do you have any issue in the follow-up, or else we can proceed with the matrix?
How to give the comments for this thing?
So you can use that is hash for this. So even if you write something, this line won't get executed. Or else if you want a very big text or something, you can add a text where you can write so many things, and then you can use list, bullet points, all those things. So when you are working on some big project or something, you might have to use so many command lines, all those things. So if it is like a basic things, you can just use hash or something. Or if it is like very big thing, you can use this plus text. Did I answer the question, Nirmal? Like, are you clear with that?
Yeah, okay.
Okay, awesome.
When you're executing something,
Shift enter.
shift enter.
Sorry.
Okay.
Yeah. Or else if we are finding the difficulty, you can shift enter or control enter, or you can press this button. It's just like a video VLC media player, like
Yeah.
the
So
start
after
button. That's it.
executing each statement, should we give
Mhm.
plus code and type the next set of codes? There is a button
If for
called
example,
code.
if you are in this line, if you are writing, so let me write next line, and if you press
Okay.
shift enter, automatically it will prompt you to the next line. So a new
Okay.
line will be whenever you write the code, so you can use shift enter. So rather than using your mouse coming here and then using this line,
Okay.
so when you are here, if you press shift enter, a new line keeps on generating.
Okay.
But we have to write something and then give shift enter.
Okay.
Or else if we, for example, suddenly if I want to insert a line here, you can just
Okay.
go and insert here.
Okay.
It's just like it is called an IPython notebook file, that is
Okay.
intelligent Python notebook file. So if you take Java or some other C program, when you write all the programs, then only you can execute the code.
Okay. Okay.
If for example, if I use that one, see automatically it's printing rather than even it's a print line also is not needed. So it's like executing each and every line so that you will know the flow of the code and then what's the output it's giving. So that it will be very easy for you to learn Python, all those things. Once you are well versed all those things, there is a file type called .py file also. You can you
Okay.
write the whole code in the form of script or something from the header files to thing, and then you can execute at the same time. But it's a very good practice to follow like this, so that it will be easy for you to understand. Like whenever you are executing, you can see the output, means you can easily correlate how it works.
Okay.
So guys, can we go with the next thing is called matrix? Can we, if you can, guys can get with the vectors and the running, all those things. If you guys can vote for me to go for the next concept, I can go. Or if you need some more time, you can use, no issues. Or if you have any doubt also, please ask me. I will help you on that.
We can proceed.
Super, super. Thank you. Okay. So next is, let's define matrix. To define a matrix, it's very simple. You have to define a variable, this mat1, and you have to define np. So np is nothing but our header file, that is inbuilt libraries that we'll be using, and then you have to click write matrix. So here you would have wrote array, right? So similar to that. So rather than that, you can write a matrix. And guys, just please be aware, like Python is like sensitive. For example, if you're rather than small case, if you're writing as capital A, it will throw you an error. So no attribute called array. So even if you're using some NP or something, it's case sensitive. It will throw you an error. So please be caution on that. NP dot array. Okay. So here, for one list, we will be giving like 1, 2 something. So since matrix contains two-dimensional more than that, we have to create as 3, 4. So now we have to enclose this in the square bracket, and then you can use it here. Just for your drill down, I'm just using like this. Now if you print mat1,
So for a vector, we have to use array, and
yeah,
for
I'll
matrix.
just go through.
Okay.
Yeah, it's ideal to use in dimension. For example, now my objective is I want 5, 10, 3, 9. So first I will define this part. This is a row vector. This is one row vector. So now what I will do is mat2 np dot matrix. So here I will just give 5, 10. This is one row matrix. So whatever we are seeing, we learn theoretically, we are just trying to use it practically so that it will be a very good experience for you to learn. And then 3, 9. And we have to encapsulate with this with a initially one square bracket at the starting with a square bracket. And if we can run it, so this is the matrix 2. So this is how defining a matrix. /assign.
So we need to use 2 square bracket and 1 round bracket, correct?
Yeah, exactly. So it should be encapsulated so that it can think that's a matrix. If it not, it will be a separate element. So a matrix is nothing but a combination of vectors. So for example, new vector 1 equal to 5, 10. So here we are just stacking up. np dot array of n. New vector 2, 3, 9. Next I will use print new vector 1, print new vector 2. If you oh 900, sorry, 9. So here we are defining that as a separate two vectors. Here we are just encapsulating it so that it becomes a matrix. Please take 2 minutes time to understand this code, and then
Yeah, can you
you
go?
just try to execute, or we can go ahead.
No. I want to go up. Can you move the cursor up?
Oh, sorry. Let
And for
me move.
printing the vector, you're using print of vector, right? But for matrix, you need not give print of matrix one.
No, we can give. It's like intelligent Python notebook, so it will
Okay.
automatically print. So if you take, it will print. Even if you're not giving also, it will just print. But if we, what happens is, if you're now we are printing new vector one, new new vector 2, it will just print the first thing only. Sorry, second thing. So whichever comes the last, it will print. So to avoid that, I have used two prints so that we will get the two print statement. So if you can run this, it will be like 5, 10, 3, 9. So you can print like new vec 1, or you can use print. So within a single cell, if you have multiple things to print, you can use a print statement. If you have only one element to print at the end, you can just use the variable name. For example, if I use 5, right, it will just print 5. If I print 5, 10, it will just print the 10. If I want both the thing, print 5, print 10. Did I answer your question, Nirmal? Is it clear now?
Yeah, Arjun.
Yeah. Let me go up so that you can see this code once.
Yeah.
Is it fine, or do I need to move up or down? Please guide me.
It's fine. It's fine. It's
Okay.
fine for me.
You just in 2 minutes, you just try to understand and try to execute in your code. Once it is done, we can just move it further.
I have one doubt, Arjun.
Yeah, please go ahead.
So, well, defining mat one, it comes as
Okay,
when you are executing mat one, it comes output comes as matrix of 1, 2, 3, 4.
exactly.
While executing mat2, it just gives 5, 10, 3, 9.
He, yeah, here we are printing just the values. But if you're going to
Okay.
print the variable, it will just show you
Okay.
what kind of variable also it is.
Oh, so it will
See?
include matrix also, since the variable
Yeah,
type is
if you
matrix.
exactly. So if you take
Hmm.
type of mat1, it will show a matrix.
Okay, okay, fine, understood.
So it's just printing both the variable type and then the values. If you want just the values, you can just use like that. If you guys okay, can we proceed with the next step? Nirmal, Veer?
Yeah, yes, okay.
Okay. Okay. Okay.
Okay, so no, okay then, super, awesome. So now we have learned about how to assign a matrix, all those things. Now let's check with matrix addition. So let us first initialize matrix 1 equal to np, that is numpy dot, we want a matrix, so that we are giving a function called matrix, and then we will be using 1 comma 2 3 comma 4. So this is for matrix 1, that is a matrix. So let's take, rather than 1, let's take matrix A. Defining matrix A with values. Then we are for another matrix, matrix B equal to np, that is numpy dot matrix of 2 comma 4 1 comma 2, some random values. Defining matrix B with values. So if we can just print matrix underscore A, matrix underscore B. So before we have seen the initialization process, right? So it's just the same thing. Now we want the matrix addition, so we can just define a variable matrix adder equal to matrix if you print matrix adder. So the beauty is this variable is auto-defined based upon, since the RHS is a matrix value. If you can just recollect C or C++, first we have to declare a variable with their data type. But here we don't need to define a variable. Based upon the value it determines. If you want, you can use typecasting, that is forcefully you can just change. For example, if you have a float value and if you just want to int, let me just give you a quick example and then I'll just jump back with this addition, because since Python will be somewhat new for you. For example, if I say float equal to 4.6789, if I print from the float, now if you want the value of, if you want to have the value of a single value, then you can use the typecasting with this FLO. If you print single, you'll just get the value as 5. So this is an integer and then this is a float. Could you get this concept, guys? So that's where by default, when you give matrix adder equal to matrix of A plus matrix of B, it gives you automatically a data type as matrix. And if you can remember in C or C program, you would have used 2 for loops, that is for accessing one element, all those things. Since we are using this NumPy, that is this header file, right? It will be very easy in terms of matrix addition or multiplication. And if you just want a multiplication, you just can give like this. So you will get the value. Now let's drill down with this matrix multiplication addition. So here we have value as
Arjun, if you are not using NumPy library, we have to give the
you have to use the for loops.
Okay.
Here also again in the back end they will be using the for loops, but it will be an optimized thing. In Python, the golden thumb rule is we have to stick with the inbuilt function as much as possible, so that rather than a single for loop, if you are going to use inbuilt function, it will be like 150 times faster or 100
If you are
times
using
faster.
that software ideally for Python.
You are asking which software to use, right?
No, I think I had installed before ideally software Python.
I haven't heard ideally because there might be multiple things, but I would like to
Okay.
suggest you could use Anaconda.
Okay. It's a
Let
open
me.
source software?
Yeah, open source.
Okay.
I'll just write the name. If I also, because this will be predominantly used in many corporates.
Okay.
And it is very good to use, and if you it will be very easy for you to install also, in the sense it will be just like a setup installation of double click install next, it will be just install, and it contains both Python and then R also.
Okay.
On top of that, it has this intelligent Python notebook and then normal Python also. So if you want to use this under Anaconda, there will be a software called Jupyter Notebook also. So one day we can sit for this installation, all those things.
Okay.
Since if we can take installation, it might take some time. So so that I don't want to waste your precious time. Even you just try with your with YouTube or something, like how to install Jupyter Notebook or Anaconda or something. I will just share you this. You just make a note of these two names. This is the whole thing. Under Anaconda, there will be Jupyter Notebook. So if you take Jupyter Notebook and if you go to images, so it will be like this. You can see this part, right?
Yeah.
So it is like your local system where you can save the program in your local files, all those things. At the same time, it will be similar to what we are using it currently now.
Okay.
So this is the concept of how it got the variable itself. And let me just go with some examples like how it has added. So initially we gave the value as 1, 2, 3, 4. This is matrix here. And then this is 2, 4, 1, 2. This is matrix B. And if you want the output as C, so 1 plus 2. So 1 plus 2 will be 3. So that is the element. This element is called 0, 0. This is the 0, 1, 1, 0, 1, 1. If you take 1 plus 2, it will be 3. And if you take 2 plus 4, it will be 6. And then if you take 3 plus 1, it will be 3. Sorry, 4. And if you take 4, 2, it will be 6. So this is the added matrix value. And if you take for this is addition. And in case if you want the multiplication, 1, 2, 3, 4, 2, 4, 1, 2. Okay. So here we will take the first row matrix and then we will multiply with this first column matrix. So if you take 2, 1, this element with this element. So 2 plus 2 into 1. This will be 2. So this is element 1. And for second thing is like first row and then we'll go with the first column. So 4 plus 4. Here we will go with second row, that is 3, 4. We will multiply with the first column. Here if you take, it will be 6 plus 4, and here again it will be like, if you follow the same concept, 12 plus 8. Now we have to just add up. 4, 8. Here it will be 10. Here it will be 20. So if you can see, the output here is 4, 8, 10, 20. So this is how the matrix multiplication works. And the second concept that we are gonna see here, or else can I give you just like 2 minutes time? Can you just go through this and try to execute in your console?
Okay.
Okay, take your time. Guys, if you are okay, can we proceed further?
Yes.
Oh,
Yes,
okay,
sir.
thank you. Next we can see is okay. Next we can see is transpose. Though it might be you might have gone through this concept in your schooling or college, but it's very good for you to practice in Python console, and it will be a very good hands-on experience also for you, because when you are learning some algorithms or handling some real-time projects, we will be predominantly using all these concepts. So for transpose, it is there are some, it is very easy for you to do transpose of matrix. Now let's take this matrix. Okay, let's define a new matrix so that it will be good practice for ourselves. New matrix equal to np dot matrix of, first we will define 1 2 3 4. The next element is 2 4 6 8, and then we will encapsulate with starting and the ending bracket. Now let's just run to check everything is good. Now it's good. Let us print new matrix. Now let's just transpose the new matrix. We can use this variable dot t. Next we are going to print it with transpose of matrix before transpose. I'm just reformatting so that it will be very easy for you to guys compare. So ideally, before we have two row matrix, see two row matrix exactly, and then this row matrix is converted in the form of column matrix. So here, if you can see 1 2 3 4, it is lies in the row, and here it is converted as 1 2 3 4. 2 4 6 8 is converted in the form of column matrix. So I will just you guys can take another 2 minutes. You just try within your console this transpose of a matrix. After that, we can see the inverse of the matrix. With this, I will share you the new concept, like how we can solve equation through matrix also. Guys, if you are okay, can we proceed to the next concept? Inverse in Python.
Yeah.
Super, super. So if you want to go with inverse, let us first of all I give you some example, and then we can see the code A, B, C, D. So this is a matrix here. If you want to find the inverse, the concept is we have to swap A and D. This is an easy trick. D A and then minus C minus D. So for this alphabet, you can substitute a number. For example, if you have 2 and 3, you have to use it as minus 2 and minus 3. Here 1 and 3 is there. You have to just swap it out. And we have to find the determinant of the matrix. AD minus BC. We will go through a real example, and we will solve an example with this also. First, we can see with this Python like how to do an inverse. For this inverse, we have to import a library from NumPy itself. That is from NumPy dot linear algebra, LINALG, import inverse. So let's define a matrix for inverse before inverse np dot matrix here you can give an example like 2 comma 3 3 comma 2 print matrix you can use this variable name and can check like how it is printing. Yeah, we are getting a normal matrix. Now to do the inverse, it's very simple. Matrix after inverse equal to INV. That is, you can see this is the keyword that we have imported here of matrix before inverse. So if we can print matrix after inverse, you will get this value. So this is called matrix inverse. After inverse so before inverse, this is after inverse. With this, I will show you in the upcoming another few minutes. I will show you an example with this also. In terms of Python, can you guys follow this, guys?
Yeah, Arjun, give me 1 minute.
Yeah. You please take 2 minutes of time and just understand this code. I will just I will just show you a real-time example with the help of A inverse. That is inverse of matrix here. if you guys are okay, can we proceed? Nirmal,
Yeah.
Veer?
Yeah.
Yeah.
How
So
did
in
you arrive
matrix,
at minus 0.4?
that is through this formula. For inverse, there is a concept called finding the minor, all those things. I hope you guys have learned in your school days or college days how to do matrix inverse, all those things.
Right.
Let us take this example. You want me to solve this value with this inverse, or
Right.
what do you?
The only the solve the inverse of
Do you want me to solve, or?
yes. Just to give an example. Only one.
Okay. Yeah. Okay. So it's 2, 3, 3, 2. As a first step, what I'll do is I just swap these two variables. That is 2, 2, and then here I'll just negate the value. So minus 3, and in front 1 divided by, so that is AD minus BC. So this is, let's take, this is A, B, C, D. So AD is like 4. One second. Yeah, it's 4 minus BC. B is this term, C is this term. So 3 threes are 9. If you take, it will be like 1 by minus 5, 2 minus 3, minus 3, 2. And if you do minus 2 by 5, minus 3 by 5, sorry, here it should be plus. Minus 3 by 5, 2 by 5. If you can just open your calculator, 2 divided by 5 is 0.4.
Right.
Oh, sorry, it should be minus.
No. Yeah.
Since minus 5, 2, it should be minus. I just, so minus plus, it should be minus. Plus minus, it should be plus. Here it should be plus. Here it should be minus. So that's where here minus 0.4, 0.4. If you go here, minus 0.4, minus 0.4. If you divide 3 divided by 5, it is 0.6, 0.6.
Right.
Are you okay, Veer? Is it convincing?
Yeah.
Super. Thank you so much. So next, there is a concept called, hope you would have came across this, A into A inverse equal to identity matrix. Have you guys came across this concept? I'll just show you this, how it works also. This is a property of a matrix, property. Like generally you can take as a formula or something. So to prove this, we can just take output equal to, before inverse, we will take that we can take that as an A matrix before inverse asterisk matrix after inverse, print output. Can you guys see, it's like identity matrix. since it's like it is expressed in the form of scientific term, but the output will be like 1 1 0 0. Okay guys.
Yeah. So floating point
Okay.
arithmetic notation, na?
It's like, since it's showing multiple digits with the floating number, it's a thing, but obviously you will get identity matrix.
Right.
Okay, then we will go into a concept that we spoke about earlier. Here we solve this equation, right? Now
Right.
we can see like how we can solve using matrix. For example, since we are using two variables, two unknown equation, we follow the traditional method. If it is like very big number of unknowns, it will be very difficult for us to solve. Hence, I will just show you a very good example so that you can understand why linear algebra is important. Because if we have to focus on fundamentals so that we can construct so many learning layers on ourselves. Now, if you can take 2x, let me take a screenshot. Okay, it is the case. Now what we are going to do is we are going to just rephrase it in the sense 2 3 3 2 x and y 8 7. It's just like we are just redefining in a way. If you can, from this equation we can go back again. For example, if you get 2x 3y equal to 8, if you multiply this with this, right, 2x 3y equal to 8, and then 3x 2y equal to 7. Can you understand this, guys? Veer and Nirmal?
Yes. Yes.
I'm
Yes.
just
Yes,
rephrasing this
Arjun.
equation in the form of matrix. Super. Now let's take this as a matrix A, and then this as a matrix X, that is an unknown, and then we'll just take it as B. With this property, we can add A inverse in both sides. In the sense, A inverse into A X equal to A inverse of B. It's just nothing but multiplying by A inverse. So when you, as previously seen, if you multiply A and A inverse, you will get an identity. Identity is like 1. So this will be an identity matrix, that is I. I is nothing but 1. Ix equal to A inverse of B. So for A inverse, we can use, that is, let me check the inverse, minus 2 by 5, minus 2 by 5, 3 by 5, 3 by 5. This is okay, right? Because we have just solved in the previous step, right? I'm just using this inverse. With this, I will just multiply with B. B is 8 and 7. Okay, then we will just do the normal multiplication, in the sense minus 16 divided by 5 plus 7 3s are 21 divided by 5. Here it's 21 8 and 24 divided by 5, and here it will be like minus 14 divided by 5. if we can just do the addition, it will be 5 by 5, and here it will be like 10 by 5. So if we can even more deduce it, it will be like 1 and 2. So this is the unknown value of x, this is the unknown value of y. So to prove this it's correct, 2x plus 3y equal to 8. So I'll just use this space, 2x plus 3y equal to 8. So if I'm substituting x equal to 1, it will be 2 plus y, 2 equal to 3 are 6 equal to 8, 8 equal to 8. So with this way we can solve n number of unknown equations. This was pretty easy, right? For two variables, that's fine. But if you can imagine, if there is 100 unknown variables or 1 lakh unknown variables, so to find the A inverse and then just do the matrix multiplication, you can easily follow rather than doing so many of substitution and then changing sign, all those things. So this is how we will find new values in machine learning. Beer and Nirmal, can you understand this concept?
Yes, Arjun, fine. Yeah.
Super, super.
Yes, sir, we understood. The thing is, how did you arrive at the denominator 5? Denominator 5, 16 by 5.
This is multiplication here with this term. So this is
No,
minus
5
2.
digit. How did you arrive at? Is 2 plus 3 5 or 3 plus 2 5? Correct?
Before that, I solved you the matrix A inverse, right? If you solve 2 divided by 5, it will be like 0.4.
Right.
This is 0.4. Before that, I solved you, right, with the steps of
Right.
A, B, C, D. So I just use that output value here, so that again we don't want to solve it again, right? So so this is A inverse that we found, and this will be the B value. If you just do the matrix multiplication, you can just easily find the unknown values. So with this help of this, we can able to solve any number of equations. This is the core concept of machine learning. That will be very useful for you guys to learn. And in terms of interview, or if you want to change your career also, this if you know this math, or if you know, like, okay, you know this concept, it will be very more easy, and for you it will be very more confident to attend the interview. So if you have this kind of big dimensions, and if you have so many unknowns also, with this matrix A inverse and then identity matrix and then multiply with this simple multiplication, we can just easily solve and find the unknown equation.
It will be applied.
Yes, Veer?
Where it will be applied? This linear algebra.
So for example, if you're for example, in terms of real time, you have a team, league, year, and whether they're gonna win or not, right? So or else you have a team, all those things, and you have a budget, and how the budget is. If you take this example, you know, most probably in our childhood, they would have teach like 2 oranges is 8 rupees, 3 oranges, 2 apple is 7 rupees. So what is the unit price of apple and orange? So with this example, if you can correlate with this, like if I have value this, then what will be my final output? For example, here you have deduced the final output as 8 by finding the unknowns. So similarly, I have values like this. What will be my output? What will be the budget for this team, and what will be the revenue of this team? Like that, we can find out. You got it, Veer?
Yeah. Okay.
Yeah, because in a real world, we will be seeing in the form of rows and columns, but the computer sees in the form of matrix and vectors. So now, if we can understand that, when you are working on some problem or real time, it will be very easy, because if you know how the system behaves, you can easily reduce like what's happening and how it needs to be done. So for a practice, I would suggest you use like when you get some free time, until we meet next week, you can just go with some matrix, define a matrix and try to do matrix. Whatever you have done, you just take your own example and try to do execution. and then you just try to transpose and inverse a matrix. At the same time, try to solve a 2 cross 2 matrix also. So you can just, whatever you have tried, you just try with your own values, try to execute, because if you can get well versed within Python, whenever we are learning something new, or if you can see this example, right? First of all, we took so much time here for vector initialization itself. After that, when it comes for matrix, vector is a common part. And when we are doing multiplication, division or something, it is like initialization has become an hygiene part. That is, in the sense, we will be using multiple often. So I would suggest you to get hold of this concept. And since you guys might be new for Python, you just have some hands-on experience also. So practice this concept, whatever we have spoken. And then this is the step-by-step approach. So here x is the unknown, a is the matrix, b is the output, and we are just multiplying with the a inverse both sides, and a into a inverse equal to I, and then x equal to b into a inverse, and then we have to calculate a inverse through, we have seen here, right? A inverse we have to calculate. With this, we multiply with b, we will get the unknown values. So this is how some basic introduction about linear algebra, matrix, vector, scalars, all those things. So if you understand this concept, it will be very easy to learn, and then it will be interesting to learn machine learning, and how the people have defined a system can learn something new with the help of linear algebra and probability. So next week we will be seeing probability. So how a probability would be helping us. So as a thing, yeah, we'll be using probability for constructing learning system and then analyzing a learning system. So if you take the real-time applications of machine learning, right? So it will be like, what is the probability of rain today based upon the precipitation, humidity, temperature, all those things. If you can give this record to the system, it will just say like, okay, today the chances of rain is 10% because the climate is too high, the humidity is low, the precipitation is very low, so the chances of rain will be very less. And for example, if I'm just giving an image, so what's the probability? It will just find out based upon the matrix multiplication, division, all those things, and then it will just predict out it is likely to be an flower image with a probability of 90%. So here comes the importance of probability, because when you take when you just normally see some machine learning models or something, at the end it will be using the probability. If you can understand this, rather than using it as a black box, you can use it as a white box. In the sense, you will know in and out of how the working is, so that you can easily work on those concepts. So to just give a brief summary of like what's gonna come next, probability distribution has like discrete random variable and then continuous random variable. Discrete random variable is in the sense, if you're gonna predict whether it's like male, female, or dog, cat, so discrete is 0, 1, 2, 3, like that. But continuous random variable is like a weight can be 55.95 to height can be 5.61 feet. So if you can understand this, it's just like a class. If okay, if a student is class 1, class 2, class 3, A section, B section, C section, means it comes under discrete random variable. If it defines about what is his weight, what is his height, and what is his salary, all this comes under continuous variable, because even in paise or even in rupees, like what's your package or what's your salary, means if it is like 50,000 per month, means it could be 50,591 0.55 paise. So that's a continuous random variable. So this is just a brief introduction about probability distribution. So hopefully we will be seeing next week, and we will be going through the statistics and probability concept. So once we can understand all this calculus, statistics, linear algebra, then if we can go into machine learning concept, it will be a piece of cake for you guys to learn. So finally, I think the end of session is here. Happy learning, guys. Like if you have any questions also, please ask me. Let's discuss and mind this session up.
I don't have any, Arjun.
Okay, Veer?
No. As if no.
Super. Thank you guys. Like it was an making this as an interactive session, and Veer and Nirmal, you guys asked very good question, and it was like very good learning for when you Nirmal ask questions, it will be a very good learning for Veer. At the same time, if you are, it's like when we ask questions, we learn so much. And thank you for making this as a very interactive and very good session. Thank you guys.
Thank you. Thank you.
Enjoy your Sunday. Bye bye.
Thank you.
Bye.
Bye bye. Mani, are you there?